When most people picture a planet with rings, their mind immediately jumps straight to the magnificent, glowing halos of Saturn. But actually, here's a little cosmic secret that might surprise you. All four giant planets in our solar system have rings. Yep, Jupiter, Uranus, and Neptune have them too. So welcome to this explainer on the dynamics of planetary ring systems. Today, we're going to explore the breathtaking reality that these beautiful structures, they aren't permanent. They aren't just eternal fixtures hanging out in the night sky. Instead, they have a highly dynamic, evolving, and very finite lifespan. They're born from total chaos, they live incredibly active lives, and eventually, well, they die. Think of me as your cosmic tour guide today. Here is our roadmap. First up, the birth of rings. Second, we'll look at the four ring giants. Third, cosmic traffic controllers. Fourth, the inevitable death of rings. And finally, we'll imagine Earth rings and look beyond our solar system.
All right, let's jump into Section 1, the birth of rings and their violently chaotic origins.
Okay, let's dive into this. Because planetary rings aren't just solid disks like an old vinyl record. They're actually made up of billions, sometimes trillions, of individual particles. We're talking everything from microscopic specks of dust to literal mountain-sized chunks of ice and rock. And they usually form through a fascinating mechanism called the Roche limit. Basically, this is an invisible boundary surrounding a planet. Just imagine a perfectly happy moon orbiting a giant gas planet. If that moon wanders just a bit too close and crosses inside the Roche limit, the planet's immense gravity starts pulling way harder on the near side of the moon than on the far side. It's a cosmic tug of war. And eventually, these extreme tidal forces completely overwhelm the moon's own self-gravity, the internal glue holding it together. The result? The moon is literally torn to shreds, creating vast clouds of debris that eventually spread out to form a ring. It's really wild to walk through the entire lifespan of a ring system, especially when you contrast our incredibly short human timescales with the vastness of cosmic time. So at time zero, a moon crosses that invisible Roche limit. In a matter of just days or maybe weeks, it's completely destroyed. Over the next few years, that massive chaotic cloud of shattered debris smooths out into a beautifully organized orbit. But skip ahead millions of years, and a process called ring rain begins to slowly deplete all that material, ultimately leading to total dissipation after hundreds of millions of years. So what we're looking at is basically a spectacular, slow-motion disappearing act. Moving right along to Section 2, the four-ringed giants. Let's look at the adulthood phase of these systems. Now, what's really interesting about this slide is how wonderfully diverse the composition and visibility of these rings actually are across our gas giants. Take Jupiter, for instance. Its rings are super faint and made almost entirely of dust, which makes them incredibly difficult to spot from Earth. Saturn, obviously, is the absolute showstopper of the group, boasting these spectacular rings made of mostly water ice. But then you look at Uranus and Neptune. Their rings are dark, narrow, and highly irregular. They're packed with space dust and dark, carbon-rich material. They are just entirely different beasts. And just to give you a concrete sense of scale and the sheer complexity across our solar system, here's a quick tally of the major ring groups for each planet. Jupiter has 4 major groups. Saturn boasts 7 major regions, named A through G, but they contain countless tiny subdivisions within them. Surprisingly, Uranus actually takes the numerical crown here with 13 distinct major rings. And finally, Neptune comes in with 5 major rings, featuring these really fascinating dense clumps of material known as ring arcs. But you might be wondering, why do they look so completely different? Well, ring colors actually act as natural identification markers. Saturn's rings are a brilliant, glowing white because they're absolutely packed with freshwater ice particles. Think of these icy chunks as billions of tiny little mirrors floating in space, brilliantly scattering the sun's white light right back at us. On the flip side, the dust-rich rings of Uranus and Neptune are full of this dark, carbon-rich, space-weathered material. So instead of acting like mirrors, these particles act more like sponges. They just absorb the light, making them appear incredibly dark and faint. On to Section 3, cosmic traffic controllers. This is how the whole system stays together. So how do these massive structures manage to stay so neatly organized instead of just, scattering into chaotic, messy dust clouds? It all comes down to these cosmic traffic controllers. Step 1, tiny satellites known as shepherd moons orbit right near or even directly inside the rings. Step 2 is where the magic happens. Their gravity gently nudges any unruly stray particles right back into their correct lanes. They literally act like gravitational shepherds, keeping their flock confined. And finally, step 3 shows how orbital resonances, basically the gravitational rhythms between the planet, the moons, and the ring particles, carve out completely empty gaps, push up spectacular vertical waves, and create those incredibly intricate spiral patterns you see. Because of these strict gravitational rules, we get an astonishing physical paradox. Just look at this scale. We're talking tens of meters. That's the actual thickness of some of these ring sections. Think about that for a second. Saturn's rings span hundreds of thousands of kilometers across the solar system. They are massive and sprawling. Yet structurally, they are managed so tightly by these gravitational forces that they are essentially paper thin. Literally just tens of meters from top to bottom in some spots. It's mind-blowing.
Which brings us to a slightly more tragic section 4, the death of rings. So the crucial point here is that perfection never lasts forever, especially in space. Like I mentioned at the start, planetary rings are definitely not permanent. They are temporary structures that are constantly fighting a losing battle against 4 relentless destroyers. First up, planetary gravity is constantly dragging particles into a slow inward spiral. Second, sunlight, solar radiation, is literally pushing the tiny dust grains away. Third, all those particles are continuously colliding with one another, relentlessly grinding massive objects down into tiny pebbles and dust. And fourth, the planet's magnetic fields interact with charged particles, messing with their delicate orbits. It is a really harsh environment out there. And this leads us to a pretty mind-blowing modern discovery called ring rain. Scientists studying Saturn have found undeniable evidence that ring particles are currently raining down, just slowly falling right into Saturn's atmosphere. Because of this relentless strain, modern research suggests that Saturn's magnificent, iconic rings might gradually disappear completely in just 100 to 300 million years. Now, from a cosmic perspective, that is the blink of an eye. Saturn's most defining feature is really just a temporary fading beauty. Finally, Section 5, Earth Rings and Beyond. Let's bring this science a little closer to home. It's kind of wild to think that if humanity had evolved a few 100 million years later, we might have never even known Saturn had rings at all. But what about our own planet? Let me pose a question to you. What if Earth had rings? And actually, it's not just a fun sci-fi fantasy. Surprisingly, scientific models suggest Earth may have briefly possessed its very own ring system billions of years ago. When that massive collision occurred, the giant impact that we believe created our moon, Earth would have been surrounded by a massive debris ring for a short period before that material eventually clumped together to form the moon we see today.
Just vividly picture what that would have looked like to stand on Earth. You wouldn't just see a plain blue sky. You'd look up and see a brilliant arc crossing the heavens, visible day and night. Depending on the season, the rings would cast massive dramatic shadows across the Earth's surface, and we'd be treated to spectacular, frequent eclipses. It would undoubtedly be one of the most dramatic and breathtaking sights imaginable.
And this brilliantly illustrates a much larger point. The cosmic cycle continues. Sure, Saturn's rings are dying, but new rings can be born at literally any time. A new moon could cross a planet's Roche limit tomorrow and get shredded. Major asteroids or comets could slam into existing moons, blasting fresh debris into orbit. Planets can even capture entirely new passing objects. And as scientists peer further out into the dark, we're already finding evidence of rings around exoplanets, distant dwarf planets, and even small asteroids in deep space.
As we wrap up this explainer, I really want you to remember this key takeaway. Planetary rings are absolutely not static, permanent ornaments. They're an ongoing, breathtaking story of cosmic change, motion, and evolution that has been unfolding for billions of years. Rings can create moons, and destroyed moons can create rings. It's a remarkably transient, fleeting beauty. So I'll leave you with this final thought to chew on. If Saturn's magnificent rings are just a temporary passing phase in the grand timescale of the universe, what other hidden, fleeting wonders might be waiting out there for us to discover before they fade away forever?